Okay, let's get started. This is our chapter 3 Kahoot game. If you can't see it up there, maybe you can see it on your screen a little better. It's really small up here. Okay. So good job. Let's take a look at this. So we need to learn how to solve the equations when we have more than the two numbers. And so we need to know the order of operations. So it's one thing you want to focus on in this chapter, as well as input and formatting output, but how to formulate equations. And so remember that we don't do addition first because that's later. And so we have to do multiplication, division, modulus from left to right. So we start at the equal sign and we work our way across left to right and we solve all multiplication, division, and modulus. So we would divide 8 by 9, but because 8 is an integer and 9 is an integer, it doesn't have a decimal on there, then you're going to get the integer version of that. And so you would get 0. Okay. Now, if one of them had the decimal point, then you would get the decimal answer. Now, if they were both variables, then if one was a double, you would get the double. If they were both integers, you would get the integer. So 2 integers make an integer when you're dividing, and 1 decimal makes a decimal. Okay. So you get 0, and then you add 1 plus 0, you get 1, and then you add 1 plus 1, and you get 2. Okay. Everybody got that? Okay with that? Okay, so don't forget about integer division, and then we divide first before we add. Okay, good job, guys. So I think this one must have been pretty easy. So this is just the shortcut operator. So if A is 3, and it says A plus equals 9, just to make sure everybody's okay with this, we're going to take the 3 plus the 9 and we're going to put it back into A. So we're just going to add 3 to 9 and we get 12, and then put it back into A. So anytime we do like A plus equals, or anytime we do the shortcut, it puts it back into the variable. So remember, it actually replaces it. So when you print out A, it should be 12. It's another word for saying A equals A plus 9 or plus 3. Was it 9 or 3? No. Okay, let's take a look at this. So this one just takes some practice. Probably when you're doing your output, just try to use fixed and try to use show point to see the difference between the two. I usually use fixed, but I just wanted to show you show point is kind of different. Fixed makes sense. It's always just that number of decimals. So if you do set precision, it's that many decimals. And if it doesn't have that many decimals, just add zeros wherever it doesn't have those numbers. But if you use show point, if you had a number of like 5.5, it would actually take the 5, and then because that's one number, it would take away from this 6, so you would only have 4 places left for decimals. So remember, the whole numbers actually count as part of that. So if you had 6, then you would have 5 decimal numbers, right? So we have 6, 1 here, and then 5 decimals. So 1, 2, 3, 4, 5. Everybody okay with that? I know it's kind of strange. It's a way to make sure everything has the same number of digits. Okay. So we got some good answers here. So let's take a look at it. So first we have to do parentheses first. Anytime there's parentheses, and if there were inner parentheses, we would do this first, but we do the 1 divided by 4 because it's not just 1 divided by 4. If it were 1 divided by 4, the answer would be 0. Because it's 1.0 divided by 4, you're going to get the decimal number. So it should be 0.25. So 1/4 is 0.25. And then you're going to take and do the 9 modulus 3 first before you add. So 9 modulus 3, if you say how many times does 3 go into 9, it goes in evenly because 3 times 3 is 9. So there's nothing left over. So then it would give you 0 for that because there's nothing left over. So then you're going to have 0 plus 0.25, and then so you get 0.25. So when you add them together. So this zeroes out, and this ends up with 0.25, and when you add them, you just get 0.25. Does that make sense to everybody? Okay, perfect. And I think if you take the quiz for the chapter, you'll see you have quite a few arithmetic problems. You'll see if this is something that is making sense or something you need some help with. And if you need some help, just let me know. Okay, so we have a variety of answers for this. So let's take a look at what we have. So we have to look at the order of operations. So we're not going to add the 3 plus 21 because that's not the right order, right? We have division and multiplication, but they're at the same level. And so we have to go from left to right. So we actually do the division first. Is everybody following? So we would do the 21 divided by 2. Because 21 is an integer and 2 is an integer, you're just going to get the even response for that, no decimal. You're not going to take the decimal part of that. So just chop that off. Don't round or anything, just chop it. But 21 divided by 2 leaves you with 10, right? And then you don't have the decimal, right? So this is 10. Then we're going to take the 10 times 2, right? Because we don't want to add yet. Is everybody following? So 10 times 2 gives you 20. And then 20 plus 3 gives you 23.
Wouldn't it be 10.5?
Yes.
Times 2, so it'd be 21 again.
If you had a decimal, but because there's no decimal. Yeah, I know it throws everything. If there's no decimal when you're dividing, then you don't get a decimal. I know it's very strange math, but it just, and it doesn't round either. It just chops it. It's like you just erase it like it never was there. So it actually makes division a lot easier because you only do the even division. You don't count anything left over. So yeah, and it's good for some things like we're gonna do that change program again today because I think there are some parts of it that change with this, and I think it's good practice. The change program really makes sense with why we don't want to have the decimal all the time, because if you're trying to figure out like how many quarters to give somebody, you don't want a decimal number. Like if it were to say give someone 3.2 quarters, that's not good, right? It just should say 3, and you don't want it to round. So there are instances where you want it to actually do what it's doing, but most of the time it feels like we don't want it to do that, and you think like, why would it do that? But it actually is kind of useful in some situations, not as many as it could be helpful, but at some situations. But does that make sense to everybody? So we get the integer number here, we get the whole number of 10, then we multiply it times 2, we get 20, and then we add the 3. But yeah, if there was a decimal in one of these two numbers, if this was 20 1.0 or 20 or 2.0, then you would get the decimal. Or if they're both decimal. It gets promoted whenever one of them's a decimal. But if neither of them, then it doesn't. And that always gets everybody, so. Okay, good job. I didn't have that many questions, but hopefully that helps a little bit with practicing for the quiz. And if you take the quiz and you do really well, that means that it's all good, you're understanding it. If you don't do well, make sure you come to me for some help, ask some questions if you're still confused. Because we will have a multiple choice test in this class, and I want to make sure the quizzes are practice for that. So if you're not understanding it, plus if you're not understanding it, maybe the assignments will be difficult, building equations and everything. So just make sure you're coming to me for some help if you're confused about anything you take on the quiz. Because I know you could keep taking it and get it right, but I want you to make sure you're understanding it when you get it right. You understand why it is that way. Okay. What I want to do is a couple practice problems with you. I really believe that the more you do it, the better you get. So the more we can practice it, the better. The more examples you have to work from when you are doing like your checkpoints or you're doing your assignment, you can pull up these examples and hopefully that helps you to have various things to look at. Some of the programs we do have random numbers. Some of the programs have input. Some of them have formatting with output. Some of them have more difficult equations. And so if we can use those as a reference, then that's helpful if we know where they are. So if you save them all in one place. So if you could get online GDB or C++ shell up, if you want to save these as an example to work from. So make sure you switch the language to C++. We are going to go ahead and put our name at the top of the program, and then go ahead and put today's date. And then this one is going to convert, and we'll do, let's do ounces to pounds first. I'm trying to keep with conversions that everyone's heard of that are relatively simple. So there's a lot out there, so we're trying different ones. So convert from ounces to pounds. Okay, and then what we need to do is we need to go into our main function and we need to create whatever variables we're going to use for our program. So we'll create our variable here. We'll make it a double so that we can work with decimal numbers. And we want to have a pounds variable and we want to have an ounces variable. And you can declare them all at once by just putting comma if you want, or you can put them on separate lines. I don't need to initialize them here. Initialize means gives them a value because on the next line, I'm going to ask the user for how many pounds that they have, and then I'm going to actually do a calculation for the ounces. So I don't need to, actually, I'm going to do the opposite because I'm going to do ounces to pounds first. So I'm going to ask them for ounces and convert to pounds, and then we'll do the opposite. Okay. So I need to do a cout statement, and I need to ask the user for how many ounces they have. So enter number of ounces. And again, this can be however you want it to be worded. And it's really up to you. I hope that you're getting the hang of this. It's really up to you if you want to put an end line there, because know that your blanking cursor will go on the next line if you do that. It's up to you if you want to put it in sentence format. But you have to be descriptive enough that they know what they're entering. You could just put ounces : if you want, and then that's pretty self-explanatory, but you know, enter the number of ounces. Hopefully that is straightforward. And then we need to make sure we take in the ounces, and we're going to save it in our ounces variable we created. You could call it O, but I like to be descriptive so nobody's confused about what we're talking about. So this is the output for the user, and this is the input to tell us, okay, that's going to get our ounces number, and then we can do our calculation. We have to make sure we do the calculation after we get the data for ounces, because if we do it before, we won't have that data yet, and it'll use random garbage data, and then you won't get the right number. So it's not like it saves the equation for later when you need it. It does it right where it is in the program. So if it's before you have the data, it'll calculate it before and it'll get the wrong data. So we need to put the calculation after. Is everybody okay so far? Okay, so hopefully you're understanding the process. So I already have a pounds variable that was already declared up here. So I don't need to declare it here. And if I do declare it there, then I'll have problems. C++ will complain at me, but I don't have to declare it up here. I could have said double pounds down here, right, when I'm using it. It's really up to you. I can't say double here, like with the C in, I'd have to do it before that line. But with this one, with the equation, you could put it on the same line, but you just can't do it twice. So you just have to be careful. So whatever you prefer to do is fine. Just stick with some sort of style that works for you. Okay, So if we're converting from ounces to pounds, we're actually going to take the number of ounces. So the variable that we have for ounces is called ounces. You could abbreviate it with OZ or something if you wanted to. You don't want to type that out. One thing about making your names really long is it's more likely that you'll misspell it or you'll miscapitalize something, but you know, it's up to you. It's not that long, I guess so. And then we're going to take it and we're going to divide it by 16. Okay. Now, you should look at this and say, am I okay? Now, you know that this is a whole number. This is an integer. So we have to look at this because if we were to have a smaller number of ounces than 16, and those were both whole numbers, we would get 0 because if they were both integers, but ounces is not an integer, right? So we should be okay because as long as one of them's a double, if you wanted to, you can make it 16.0 if you were, you know, not looking back at the data tab, or if you made your ounces variable an integer, if you were requiring people to type in just like a whole number of ounces, if you didn't want them to have like a half an ounce, and you might not want that. You might not want them to have a decimal number of ounces. And so if you were to change it up here, so you didn't have a decimal number of ounces, then you would have to change your equation down there so that you would have 16.0. Does everybody understand the dilemma? But right now it's okay. And the reason why it's okay is because this up here is a double. Actually, this one is a double. And so in this equation, because this one's a double, you'll get the double answer. But if you wanted to, in case you change it in the future, and you decide to make ounces an integer, you can make it 16.0 to be sure that you'll get the decimal. Is everybody with me? Okay, now when I'm doing my output, because I already have the number of ounces listed here, that already is going to be on the command line for somebody to see. I don't probably have to print that back out because that's already shown there. If I were like randomly generating the number of ounces, then I'd want to print that information because the user wouldn't have that information. So I want to know how many ounces it was that we were converting to make sure it works. But we already have that, so we don't really need to repeat it. If you do, it's not a big deal, but we do need to print the number of pounds, okay? Now, instead of just printing the number of pounds, I like to put a label with it so people know what we're talking about. So down here under our equation, we will put either you could just write pounds and then put a colon and put the pounds variable, or you can put number of pounds equals. You can put an equal sign there if you don't like the colons. I use colons a lot, but if you don't like them, you can put equals. Anything that lets you know that that is, you could say the number of pounds is, and you know, then display it. Just make sure that it has spacing and it looks good. If you're going to write it in complete sentence format, don't run your number right up against your word because it doesn't look nice in your output. Just make your output look nice. So we're going to go ahead and run this. Make sure that we get a number that makes sense. So enter a number of ounces. We know that 16 ounces is a pound. So let's try that. It should say 1 pound. Okay, what if we do 2? Okay. What if we do 18? Let's try different numbers and make sure that your output is making sense with how many. If we know that it's 16, if you try different numbers, try a number above 16, try a number below 16, try 16. Try different numbers and make sure that whatever you're getting for an answer makes sense. And then if you want to add some precision on here, we can add some precision to make sure that, you know, if we don't want to have 3 decimals like that, maybe we only want to have 2 decimal places, we can add the precision. So adding precision is the line right before, and you will have to add your preprocessor at the top, but you can just say set precision. And then how many you want. I like to have 2, but you can do as many as you think is good, right? 2 is common. And again, I liked fixed instead of the show point, but and then up at the top, it doesn't matter if it's before your IO stream or after. You can put your include, and then you want to put this IO manup, and then you can say used for formatting in case you're trying to take that for one of your programs like your assignment and you're trying to decide which one to use. Hopefully that'll help. So make sure you put this at the top. And then before you do your output, just say how many decimals you want and whether you want it show point or fixed. And then if I do that again, just to see now, I should only get 2 decimal places and it will round for you. So, you know, kind of nice to have so that you don't end up with like 16-digit decimal number. Okay, so you need this and you need this at the top. So hopefully that gave us a chance to practice. We know how to do input, I hope. We have to declare whatever variables we're using for our input before we actually input them. You always have to make sure that you have an output message that tells the person what they're supposed to be inputting. And then, you know, always name your variables with something that makes sense, that's meaningful, so people can follow your code and your calculations. After you have the input and all the data you need, you do the calculations, whether that be 1 calculation or 2 or 3. Do your calculations. And then do your output so that people know the answers. And with your output, always make sure you're putting labels so people know what the data represents. And then try to make it look nice with using precision to see, you know, so we don't have really long decimal numbers. So we probably don't need that. So it makes it look a little nicer. Okay. Is everybody clear on that? Pretty easy? Okay, perfect. So let's go the opposite way. But first, you might want to save this. So if you're you know, wherever you're saving your files, and go ahead and put this one, maybe you want to call it convert to pounds. And then I want to flip this and I want to see convert pounds to ounces. So I'm just going to change the comment at the top to flip it. And what would be really nice is when we get to decision making, we can actually take a program like this and we can ask the user, would you like to convert to pounds or ounces? And then they can decide which one they want to, and then they give you whatever value, like, is it pounds or is it ounces? And it'll give you the right formula. You know, same thing with like Fahrenheit, Celsius. We can ask, do you want to convert to Fahrenheit or do you want to convert to Celsius? And so we're allowing them to make decisions. At this point, we don't have decisions, so we have to have separate programs with different calculations because we can't ask them what they choose to do. But when we get to chapter 4, we'll be able to ask them what they want to do, and we'll be able to make decisions based on that. So it makes it a lot more flexible and a lot more exciting. But we need to have this as a stepping stone first. So I hope this is making sense. I'm going to leave my preprocessors in there because I'm going to use that formatter for the output as well. Okay, so then I'm going to change this. I am still going to need pounds and ounces. So I'm going to leave this the same. We'll come back and talk about that in just a second. So I'm going to ask for the number of pounds instead of the number of ounces. And then we're going to just change this to pounds. Okay, so I'm just flipping this. Okay, now if you're taking the number, you're trying to convert, you're going to take the number of pounds times 16 to get the number of ounces. Okay, so in here, if we just take the number of pounds, multiply by 16, and if you want to put space in here, you can. And then we're not putting it back into pounds, we're putting it into ounces. So the number of ounces is pounds times 16. And then I don't need to print pounds because I already have that information up here. I need to print the ounces, right? So I'm flipping this. I can leave the precision the same. I'm flipping this to print the ounces. And then here I'm printing the ounces. And then I'm going to go ahead. Looks good, but you never know. I mean, I could have made a mistake for sure. I could have forgot to change something. So let's test it. Always test it. Don't assume. Okay, so how many pounds do we have? Let's say we have 1 pound. That should be 16 ounces. It's going to have 2 decimal places because I told it to do that. If you don't like that, you can take that off. Okay, what if I have half a pound? Okay. 5 pounds. Okay. All right. Is everybody getting this? All right. What if I have just try different numbers, make sure it works, okay? Okay, so pretty easy. Okay. All right, so just try different numbers and it works okay. If you like it, go ahead and save it. And you can call this 1 pounds to ounces, you know, just so you have 2 different versions. One might be good enough. You might not want both of them. I don't know why it's not letting me. Okay. Convert. And you can just say 2 ounces. Just trying to flip it. There's all kind of conversions out there. So if, you know, we've tried doing all kind of things like working with inches to feet and, you know, miles to kilometers, kilometers to miles, Fahrenheit to Celsius, pounds to ounces, ounces to pounds. There's so much you can do. If you want to practice, you can just go out there and search like conversions and just kind of try to practice. And what's pretty cool is, of course, they usually have like a conversion calculator out there so you can test your program to see if like you put the equation in and then you test it on Google and see if it's the right answer. See if your program's giving you the right answer. So if you need more practice, there's plenty of things you can go out there and practice with if you feel like you don't have this quite yet. Think about like what will your variables be? What will your input be? How do you do it? Does anybody have any questions about this? I want to do that longer program because I think it's good practice. We did it a while ago with a change. And I think it's good to kind of go back through it. I know we did it, but this time we're going to do it with input. And we're going to talk about the shortcut. So this is going to be the change program. So you'll have it again. But last time we didn't do input. So we're going to change a little bit. We're not going to have output for this. We're going to have output. We're not going to have formatting for our output. So we can take that off of there. And I think this is good practice to have. So that's why I think it's good. I'm going to go ahead and delete these so we start fresh. Okay, so the first thing we're going to do is we're going to create a change variable. And we're going to ask the user to enter the change. We're going to ask them to enter the change as a decimal because I think that's the most likely way that people would enter it that makes sense to them. So what I mean by that is that if they had like $3.75, they would type 3.75 for like $3. I don't think they would type 375. So we'll have them enter it as a decimal. Then we'll take it in and we'll save it in a variable called change. And I'll pause there just to make sure everybody's with me. But I really want that variable to be in a overall variable called sense, which is the overall sense. I don't really want it to be 3.75 because it'd be easier to work with if it was 375, but I just don't think that's how they'll enter it. So I'm going to multiply it times 100 so that it makes it 375. They were to enter 3.75. So as long as they enter it correctly, because if they do enter 375, that's going to throw everything off when we multiply that times 100. But if they enter it correctly, then when it multiply, it should be right. So we're going to create a variable called sense. And we can put it up at the top. Like if you wanted to have all your variables at the top, you can create it up there. Or you can create it down below. Whatever is helpful for you. Some people like to have all their variables up at the top. So we can put in sense up there. It's an integer because when we multiply it by 100, it's going to be a whole number that we're working with. So we're going to say sense equals, and we're going to take the change divided by 100, or times 100, sorry, times 100. Just talked about that. We cannot do this equation up here when we have the variable because we don't know what that is yet. We don't know what changes, so we can't multiply it times 100. So we have to wait till after we get change to do the equation. We can declare it up here, but we can't do the calculation up there. Does that make sense to everybody? If you wanted to put the int here in front of sense, then you wouldn't need to do it up here. It's just a matter of your preference of where you want to put that. So just don't do it twice. Don't do it in both locations. Okay, is everybody following so far? Okay, perfect. Then we want to have the number of dollars. All of these are going to be integers. We're actually going to have dollars. And I'm going to write the words out so that we don't have like D because, you know, we want to know what they are. So we'll write dollars. We're gonna have one for quarters. If you want to put all your variables up here, they're all gonna be integers, so you can just put commas between them. We're gonna have one for dimes and one for nickels. We don't need pennies, and I'll explain why later. I mean, you can add it if you want to. Okay, so these are all integers. This is the decimal because when the user types it in, they're entering it as a decimal, but then we're multiplying it and putting it in the cents variable so that we can work with it with our equations. And then all of these are going to be integers because remember I said before, you wouldn't give somebody a piece of a quarter or a piece of a dime. So we don't want those to be doubles. We want them all to be integers. And you don't need to repeat int because if you just put commas between them all, then it automatically declares them all as that data type. So just as long as they're on here and not up here. Everybody okay? So I don't need to declare those again. I have those Java or C++ isn't going to let me declare those again. So be careful. So when I want to use it, when I want to do my equation, I will just say dollars equals, because I already have that it's an integer up there. So dollars equals cents divided by 100. So to get the number of dollars, we're going to divide by 100 and pull that out. So if we had 375, we divide by 100 should give us 3. And we're not including the remainder right now. Okay, so then we would have $3, right? Okay, now, if you want to test your program so far, just so we can go step by step, because last time I tried to put all the equations and then test it at the end, it's probably better to test as you go. So let's go ahead and put how many dollars it would be to make sure that's working. So we're going to print out the number of dollars. So I'm going to print out my dollars variable. I'm not going to do the rest because the rest aren't right yet because we don't have equations. So just printing dollars to see what it looks like and make sure it works because I have it here. So then if I run my program, try to go step by step, I'll type in 375, but I'll type it in with the decimal 3.75, hit enter, and it should be $3. Try another one, make sure it works. Okay, so how about 0.89? That's not any dollars, there's no dollars, right? Try some with dollars, try some without, and does it seem to be working? I want to troubleshoot as I go. So I'm going to do quarters next and we'll test it. But is everybody so far so good? That makes sense? I have a problem. If I were to go to quarters and just continue the same way I've been doing, like if I were to say quarters equals cents divided by 25, because there's 25 cents in a quarter, I would be taking the full cents that I had before the 375 and I'd be taking the quarters out of it, but I wouldn't account for the 300 that I already took out for the dollars. Does everybody see the problem? We would get way too many quarters. We need to take out the 300 that we got for the dollars, so we only have 75 cents left. Everybody with me? Okay, so that's the challenge that I have. I need to create this variable. I'm going to add it to the end of here called cents left. It makes sense to me. It could be called remainder or cents remainder. Really, it's after you take out each increment, how much is left. That's what we're trying to do because we have to pull out the increments and save it somewhere, like a temporary variable to hold it, and then figure out the next increment, and then pull it out and figure out the next one. We can't keep going back to cents because we'll have way too much money. Okay. Now, technically, I guess you could save it into cents if you wanted to replace that. If you didn't want to print that anywhere else. But we'll create this new variable for it, cents left, so it's not confusing. So cents left, here's what we're going to do. We're going to go after dollars, and then we're going to figure out the cents left. So we have to take out the 100. So we use that modulus. So we're going to say cents left equals, okay, and this is your remainder. You could also call this variable remainder if that made more sense to you. We're going to take the cents modulus 100. So what that means is take out the 100 from the cents variable and then give me the cents left. So if you were to take out dividing it by 100, you would be taking out 300, right? Because you would be getting what's left over. So if you were to take modulus 100 from 375, you get 75 left over, right? Does everybody understand that equation? Now, you can't shortcut this equation because they're two different variables. Like this one is cents and this one is cents left. So you can't shortcut it. Not that you want to, but you can't shortcut it. Okay. Still doesn't give me the quarters though. It's just a step to get in the right direction. Is everybody following? The next step, I can do the quarters. I can do quarters equals. Now, instead of using cents, because cents is we'll say 375 in this example that I'm giving you, instead of using 375, which is cents, I'm going to use cents left. Okay? And then divide how much a quarter is worth, right? So divide by 25. So if I had cents left, which is 75, now I can pull the quarters out of cents left. Okay, now that I got rid of the 300. Does that make sense to everybody? Okay, so now I should have the right number of quarters. And so if I go down here to my output now, and I can continue on this line or I can go to the next line, okay? You could just put an end L at the end of each one and just start a new one if you want. Or you can put a \n inside a string and you don't have to keep starting a new line each one. It's really up to you. If you like to have them all lined up though, I think this kind of looks nice. Then I can do something like this. So I can easily follow it. Trying not to make it confusing here. I'm just doing line by line. So whoops. Okay, so dollars and then quarters. So if I use that same example, 3.75, that's $3.75. That should be $3.75. Now, we want to test it with other numbers, right? So let's try it with 28 cents. I shouldn't have any dollars, right? But I have 1/4. Try it with different numbers and make sure that it is working. Okay. So far, so good. Okay, so now we need to think about this pattern that we're doing. We took the quarters, we figured out the quarters. But if we had we took the dollars out, now we need to take the quarters out of what we had left. Now, if we did the 375, once we took the quarters out, we wouldn't have anything left. So if I come up with a different example, like let's say 385, we took the dollars out, we would have 85 left, and we took the quarters out, we'd have a dime left, right? We'd have 10 cents left. Okay, so on the next line, what we're going to do is we have to do the cents left again. We have to figure out what cents left is. And we have to take, instead of taking the total cents, because now we're moving on. We did the total cents up here because it was our first time we were doing cents left. But now we're going to work with cents left because that's the one, like when we first took the dollars out, we took the 300 out, right? But now we need to take it out of the 75, not out of the 375. So we're going to take it out of 75, or in this case, we changed it to 85, so we have something left. So we would take it modulus 25. So this would be take quarters out. We can say here, take dollars out, if that helps you remember what's going on. Then this part can be shortcutted if you want to. Now it's kind of quite confusing when you're first looking at it. So you may not like the way it looks. So I'm just going to write it over here. And if you like it, you can do it. And if you don't, you can just do it the longhand way. Okay. So this is the shortcut that you could write in place of this. Some people don't like repeating the cents left equals cents left because it's a longer word, especially. So whenever you see that this word is repeating on both sides of the equation, you have it here. You're assigning it to the same variable that you're working with on the right-hand side with your equation, then you can shortcut it. So you just take the name of it and then the operator equals what number you're working with. Okay, so this is the shortcut. And so if you were to see somebody do this, you should know what it means. But if you want to write your equations like this, that's completely fine. You don't ever have to shortcut them if you don't want to. But if somebody writes it, you should understand what it does. Since you will be working with other people in the future, we should know what the code does. And you don't need to have the spaces here if you don't want to. I'm just trying to space it out so you can read it a little easier. And these you can have spaces if you want to. Sometimes I don't because it takes a little longer to type it, but if you want to put those, you can. And then once we have our cents left, then we can move on, right? Move on to dimes, right? And dimes, we always want to make sure we're working with the cents left because we're not going back to cents. Divide by how much is a dime worth? 10, right? So take out the 10. Actually, not take it out, just see how many you have, and then next step, we'll take it out of the remainder. So then the same thing, if you want to copy this, it might make life easier. We're gonna test the dimes. We're just going step by step, make sure something works, so we don't get to the end and have a big mistake that we have to fix for a while. So we have to go step by step and make sure that each increment is working. Let's try the 385 because that actually has a dime. I mean, you could try 375 and you won't have any dimes. Try different numbers, make sure that you have some dimes, you don't have some dimes. Is that actually working? You try 20 cents. We have 2 dimes. So try different increments. And the next thing we have to do is take out the dime. So if you've been following this pattern, see how we took out the quarter here? We need to follow this pattern. We need to take out the dime. So we would just change this to 10. And this could be shortcutted like this if you wanted it to be. And that just means that, you know, first you're taking the total number, you're figuring out how many dollars. And you got to take those out of the how much you have total. Then figure out how many quarters. Then take whatever you took out of the quarters. Then figure out how many dimes. Then take whatever you took out of the dimes. Now we need to figure out how many nickels, right? So this will get us how much is left after we took out the dimes. And then we can do our nickels. And so nickels. And we want to do cents left. Divided by 5. And that will give you the nickels. And then you can come down here if you want and test it. Do nickels. Oh, that has to be the variable name. Not capital. Make sure you spell it right. If you spell nickels differently than you spelled it up at the top when you declared it, it won't work. Up here, just make sure you have the same spelling if it's not working. And then when you run it, do something that has a nickel. I just did one just to see. 1 nickel. One nickel, 1 dime. Does it seem to be working? Got no nickels. Let's see. Okay, so try different numbers, make sure that it's working. And then we need to take out the nickels to figure out how much is left for the pennies. So we do take out the nickels. This shortcut would just be 5. Now, you don't need to do, like, you don't need to have a pennies variable because you're just going to divide by 1. And anytime you divide by 1, you just get the number again. So technically, we don't need a pennies variable because whatever's left in cents left at the right end is the number of pennies. So you can really just use the cents left variable. If you want to put the cents left variable in a pennies variable, you can, because my equation for pennies would just be pennies equals cents left divided by 1, which is just cents left. And then I don't really even need a variable. So that's what I would do. I would just use cents left as my pennies. But if you want to create a variable for it, you can, if it makes more sense to you. But I can test this by just printing out the pennies. And then this would be cents left because I didn't create a new variable for it. And then I can test it. They have 6 cents. So try it with different numbers, make sure that it works for you. I hope this gives you, I know this was a tough program when we first did it. I hope that seeing it again, doing it with input is a little more useful. And then we also were able to talk about that remainder again, which is always tricky. And then the shortcut, which we don't use that much, but this is a good opportunity to use it if you wanted to. So you can at least write as a comment to know that you can use it. And you can only use it when the variables are the same. So some of those equations can't be changed, but the ones that have the same variable repeating can be changed. Does anybody have any questions about this program? You're all good? Do you feel like this chapter is making sense? You got the input, you got the output with the formatting, you got the equations. The equations are probably the toughest part of the chapter. I feel like in the most you can do is just practice with that. If you want more practice, you can always create your own equations. You can just go into online GDB, make up an equation in the cout statement, and before you hit run, see if you can figure out the answer. So just put a bunch of numbers inside parentheses and do like multiplication, division, modulus, and then see if you can get the answer, and then hit run and see what it comes up with and see if you got the right answer. So that's probably the easiest way to practice. Also, when you take the quiz, you'll know if you're answering the questions correctly on there. And so you can always practice some more with that. And if you have questions, make sure you let me know. But that just takes practice, getting used to integer division, order operations. But we need to create our formulas correctly or we'll get wrong answers. So just trying to keep them nice and simple so that math isn't too tough. Okay, so let's take a look at the assignment.